Hi there, I'm Graham Lewis, and in this short video we're going to discuss the three problems that are shown there. A student asked me some questions about these, so I thought I'd make a video. She asked some really good questions about them. If you're wondering why I'm wearing a toque today, which is a woolly hat for those that don't live in Canada, at our high school today we've actually got a Canadiana Day, and so everyone's dressed in non-uniform with things Canadian, so I'm wearing a toque. So here we go. So here's the first one. Let's have a look at this minus 5m minus 6 equals 44. And the student asked a really good question. She added 6 to both sides, which is wonderful. So I'll get rid of that minus 6. So we'll add 6 to both sides. Sorry, just made a mistake there. And we get minus 5m equals 50. And the question was, do we divide both sides by 5? Or do we divide both sides by minus 5? And the answer is, you can do either. Both will work. As long as you do what to one side, you do to the other, it will work. But let's do it both of those ways and see which one might be quicker. So I'm going to do it first by dividing both sides by 5. Now, if I divide minus 5 by 5, it changes to minus 1. So I'd have a minus m on the left-hand side. And if I divide the right-hand side by 5, showing the working there, I would have a 10. So I end up with minus m equals 10. Sorry, I keep wanting to put a negative there, don't I? So I still have more work to do. So let's have a look at this. I want to get rid of the minus in front of the m. Now remember, that's actually a minus 1m. We never write the 1 there. So to get rid of that minus 1, you can either multiply both sides by minus 1 or divide both sides by minus 1. Both will work. I'll divide both sides by minus 1. Clearly minus 1 divided by minus 1 is m. And 10 divided by the negative 1 there gives me the correct answer of minus 10. So if you choose to divide by 5, you'll end up with minus m equals 10. So you'll have an additional step to do to get to the m by either multiplying both sides by minus 1 or dividing both sides by minus 1. Let's go back to minus 5m equals 50, and let's divide both sides by minus 5. Now, if I divide, I'll show all the working this time. If I divide both sides by minus 5, showing all the working, putting it in there, you might not choose to do that, that's fine. Then clearly minus 5 divided by minus 5 cancels, leaving me with a 1. So on the left-hand side, I'm left with a 1m. And I don't need to write the 1 in there because we know that m is just 1m. And then 50 divided by minus 5 is minus 10, and I've got the correct answer. So you can see both ways work. On the left-hand way, if you divide by 5, you'll have an additional step to do. If you divide by minus 5 both times, you'll get straight to the answer. In the second question the student asked, it was, if we have x's on one side, will it always be x's on the other side? Or maybe another letter like a p or a t or something like that. So if we're thinking about this, what we're doing here is we're solving 2x plus 1 equals x plus 8. So we're trying to find the value of x that makes the left-hand side equal to the right-hand side. So, for example, if I just guess a number like 10, then on the left-hand side, 2x, so 2 times 10 is 20, plus 1 is 21. On the right-hand side, RHAs, if I guess 10, then 10 plus 8 is 18. And clearly, when x is 10, the left-hand side does not equal the right-hand side, so therefore we haven't got an answer x. Now, we obviously are going to use algebra to find out the answer x, but the question the student asked was, what happens if it's not an x there? What happens if it's, say, a p? Well, of course, now you have to guess 2 answers that work, and there's no real algebra way of solving this effectively. You'd have to guess one answer on the left-hand side. So imagine we had our guess of x is 10 again. We've got 21 on the left-hand side. Well, clearly, to make the right-hand side 21, if x is 10, then the p number would have to be 21 minus 8, wouldn't it? And 21 minus 8 is, well, an easy way to do that is minus 10, then add 2, so 13. So, and you can see that 13 add 8 is 21. So if I let x is 10, on this side I get 21. And if I let p equals 13, on the right-hand side I also get 21. So there's one solution for that equation if it's not x's and all x's, if it's x and p's, for example. Obviously there are many others. If you let x be 5, you'll get a different answer for p. So now let's go ahead and solve it with just the x's there. 2x plus 1 equals x plus 8, which is the more traditional one in grade 8. So the first thing, I'm just going to change from red because I don't like red that much. So the first thing to notice is we've got x's on both sides of the equation. Now, of course, you can start subtracting 1 from both sides. You can subtract 8 from both sides. You won't go wrong, but I always like to get the x's on one side first. So you've got two choices. You can either get rid of the x. To get rid of the x on the right-hand side, I would subtract x from both sides. That would get rid of the x on the right-hand side, and it would be really nice on the left-hand side because 2x minus x would be a positive 1x. So that's one possibility, and that would leave me with positive x's. The other way, which still works, but I don't like as much, is getting rid of the 2x, the bigger number. If you get rid of the bigger number, you have to minus a bigger number. If you minus a bigger number, you're going to get a negative. So minusing 2x from both sides, yes, we'll get rid of the 2x on the left-hand side, but x minus 2x on the right-hand side is minus x, which is fine. It will still work. You could use the example that we just did with a minus x number. I think it was a minus 5x, wasn't it? But you're introducing a new level of complexity. Why bother doing that? So that's the first thing. Have a little bit of a think. What's the best way of doing this? So I'm going to subtract x from both sides. I'll show a bit of working on the right-hand side, but I know that x minus x is 0, so I'm not going to show the working on the right-hand side. But definitely I've subtracted x from both sides. Now let's gather our like terms. 2x minus x is an x, plus 1 equals 8. And then we subtract 1 from both sides and we get a 7. Just to show you quickly, if we had done it the other way, subtracted 2x from both sides, I'd have a 1 on the left-hand side. It would be a minus x, because plus 8. Then I'd have to minus 8 from both sides. And 1 minus 8 is minus 7 is minus x. Then I'd have to do the trick of multiplying both sides by minus 1 or dividing both sides by minus 1 to get the same answer of x equals 7. So you can see that's a little bit harder there. Let's have a look at the last third question. In this one again, we've got x's on both sides of the equation. So again, what I would do is get all the x's on one side. You've got two choices. Again, you've got a minus 9x and a minus 2x. So let's think about them separately. If I wanted to get rid of the minus 9x, you do the opposite. The opposite of minusing 9x is adding 9x. And if you did that on the left-hand side, this would disappear, of course, and minus 2x plus 9x would be a positive 7x. So that's nice. So that's definitely what I'm going to choose to do. Imagine if we did the other way. Imagine if we got rid of the minus 2x. If we got rid of minus 2x, the opposite of minusing 2x is adding 2x to both sides. Well, if I add 2x to both sides, it's gone from the right-hand side, and minus 9x on the left-hand side, add 2x would be minus 7x. It will still work, you can do it, but I'm not going to do it that way because I don't want to invent negative numbers if I can avoid it. So let's choose to, I'm going to show here, I'm going to choose to add 9x to both sides. And as normal, I choose not to show the working on the left-hand side here because I know that minus 9x add 9x will vanish. It will be 0. I know that. There's no need to show it. If you want to show it, you can show it. On the right hand side, I'm going to show the working though because it's very easy to make mistakes with negative numbers. I know the answer is 7x to minus 2x plus 9x, but I would strongly encourage you to show a little bit of working. It's amazing how we all make mistakes with negative numbers. So I'll copy down the negative 4. Minus 2x plus 9x is a 7x. A nice positive 7x. 7 is also a lovely number, isn't it, as well? It's a nice prime number. Okay, now I'm going to get rid of the minus 4. Let's add 4 to both sides. I'll show a bit of working again because I don't want to do too much in my head because in case I make mistakes. I know minus 4 add 4 is 0. I'm not going to show that working. Minus 25 add 4. Take your time. It's minus 21. So I've got minus 21 equals 7x. Now I divide both sides by 7. Clearly, I'm going to show the working again on the left-hand side. I'm not going to show it on the right-hand side. I know 7x divided by 7 is 1x. And 7 goes into 21. Sorry, that's a 1. It looks like it's changed. Obviously, it is minus 3 equals x. And I always like at the end, rather than have minus 3 equals x, because we read left to right, we write x equals negative 3 or minus 3. And there we go. There's the 3 questions. I hope you enjoyed these videos. It's great that a student asked me these questions, and hopefully you'll see that by asking questions, other people can benefit from that. So everyone, just keep asking questions in your classes. Don't forget to do these questions yourself. Watching a video is one thing, but try them out yourself. Make sure you do it. Thank you very much. Any comments or suggestions, please write below.